Okay, welcome to NVO3. Let's make a start. So here is the note well. I hope everybody has read this. And please let us know if we need to speak more closely to the mic. Okay, blue sheets. There's blue sheets going around each side of the room. Please sign that as usual. We have Ignace taking notes. Thank you, Secretary. Okay, meeting logistics. So this time it'll be a normal meeting, so we're not going to break up into round tables or anything as we have done in the past. Although we are going to hopefully ask for a little bit of discussion around some of the points on the agenda. We have a very packed agenda, so speakers, please try and keep to your time slots. Okay, here's the agenda. One slight last-minute change on this compared with one of the recent ones that was posted is that we've got an update on the Geneva security requirements. I think actually Sammy is going to present that. Any other comments on the agenda? Okay, milestones. We really do need to update these. They're not quite as behind as they have been at some points in the past, but nevertheless. So I've noted in red on these slides any changes that I think need to be done. We'll also post. I promise we'll post these to the list straight after the IETF. So the main changes on this really are just shifting some of the milestones backwards. And also, I'm going to suggest removing the operational requirements milestone. We did have a draft on this a very long time ago. I think it was last updated in 2013, around that time. Doesn't seem to be progressing, so let's just remove the milestone. I did add a milestone as well for security solutions, since we didn't have a milestone for that before. So I'm hoping that we can get most of these done by the end of this year and middle of next year. So the heat is definitely on to get through this. So any comments on the milestones? Okay. All right, document status. So I don't think we have any new RFC since the last IETF. The multicast framework is in the RFC editor's queue. Data plane encapsulation. I've chosen data plane encapsulation, which is Geneva. This is on the IETF. But ideally, like to send this for working group last call after this IETF. But we probably need some area reviews in a couple of. Well, we certainly need to do a routing area directorate review. We've never done that, I think, for Geneva. But we'll probably need a transport area review as it's a new encapsulation. We'll also need a security area review. So what we'll try and do is get those at least underway before we start the working group last call. Once the working group last call for that is underway, I think, as we said before, we'll do the design team draft, which was NVO3 NCAP, send that to the last call as well. So there's been some progress on the NVE control plane requirements in a few areas. For example, the hypervisor to NVE control plane requirements document needs to be last called after this IETF. One draft as well that we've had sitting in the working group for a very long time. There was a lot of interest in virtual machine mobility early on in the life of the working group. I think it's time really to last call this draft. We did an IPR call recently.
Yeah, I'm editor, one of the editors of this draft, and you know, this draft has been receiving very good reviews, and we just revised very minor revision, so I think that's ready for working group last call.
Okay, I just wanted to have some slides up now just to kind of review where we are with what kind of drafts we have in the working group related to some of our milestones. So around the control plane, I think we have drafts at least targeting each of the main control plane areas. One is the NVE to NVA. Well, we call it a control. I'll put it in quotes here, control plane. I think we discussed a while ago, this will be netconf, obviously, with appropriate Yang models. Now, the current Yang model that we have in NVO3 only supports VXLAN. I think really what we're looking for is a Yang model that supports Genève, since that's our standards track approach. So I think it would be very good to get to see some drafts in that space. Right.
Greg Mirsky, CT. I looked at Genève and what it might take or would be helpful to start data model work. I think that definition of TLVs, or at least some common TLVs that will be used for Genève, will be definitely helpful. Is there such work or planned work?
Could you send to the data plane or the Genève authors? Have you sent any of the?
No, not yet. I just did it a couple of weeks ago. So
okay, so if you can actually send to the email, the mailing list, I think.
Yeah, yeah, because I think that, you know, at least some generic TLVs should be part of the base model.
Okay, so the other part is hypervisor to NVE control plane. So we have the hypervisor to NVE control plane requirements, and that kind of corresponds to the VDP work in the IEEE, which is now done. So we need, as I mentioned, we need to move forward with last call in this draft. We have also discussed applicability of distributed control planes such as BGP for EVPN. So we have the draft for an applicability statement for this on the agenda. One thing I noticed earlier is that our charter is a little bit perhaps strict in not this. It literally says it doesn't mention the distinction between an applicability statement and a protocol solution with regard to the BGP control plane. It basically is it could be very much interpreted as thou shalt not talk about BGP in this working group, which perhaps we need to look at tweaking that part of the charter. Okay. Security drafts. So we have a whole set of security drafts now related to Genève, which is great. We won't discuss this immediately now, but I'd like a little bit of discussion around this when we have the discussion on the security drafts in a moment. But we do need, we're getting fairly strong guidance that we need a firm security foundation for our encapsulation. And we have a set of 4 drafts, requirements, security architecture, an authentication option, and an encryption option for Genève. The current guidance we're getting from our AD is that we really need to make some informative references from draft Genève to security solutions. And if we, to me, I mean, this does not hold up the progress of Genève, because these are informative references. But we need to show some progress in this area, and some concrete steps to making progress on developing security solutions within NVO3, really, in order to get Genève through. Now, this means we probably need to adopt those solutions documents pretty rapidly. So ideally, it's very good to make progress on the requirements and security architecture, but really the end goal is to get those solutions adopted in the working group and published eventually. Okay, the other area that I wanted to mention was OEM and how we're going to progress on OEM. So over the years, NVO3 has really had a variety of OEM solutions. We had some kind of point solutions for our non-standards track data plane, for example, VXLAN GPE, so the OEM bit definition for GPE. We've got a draft today on VXLAN BFD. There's a path MTU discovery draft. There was a draft on transcending traceroute. We also tried to adopt more generic OEM drafts around sort of encapsulation and a header for OEM, but we couldn't get any consensus within the working group to actually adopt those drafts at this stage. So given this, how should we move forward with OEM in NVO3? I think everyone agrees this is a fairly important topic. It seems to us as chairs that there's no consensus for a new generic tunnel OEM solution to be developed in NVO3. So one of the original proposals was to take routing area OEM proposals and do those in NVO3, but we've had difficulty with adopting those.
Okay.
Right?
Yes. I think that what's important here is that to differentiate active OEM and two other methods that listed here, IOM and alternate marking method, is hybrid. Because hybrid and IOM, they exist only when there is a data flow. They're characteristic of active OEM that this test packet can be injected in the network when there is no traffic. So if we consider that we need to do, for example, it's part of like service activation testing or service activation protocol. So to do verification of service without live traffic, then active OEM is strong requirement. If we think that it's sufficient to do OEM only when there is a data present, then hybrid as well. Another application of active OEM is obviously the protection, because without active OEM, we cannot monitor the protection path, as there may be no data flow. Okay, so I would clarify this question to the group is that not just OEM, but list of active OEM, because active OEM is, again, I'm using the terminology that we agreed on in RFC 7799, is a special constructed package that being injected in the network to do measurement and monitoring.
Okay, so I think this basically comes back to, and what I was trying to get to on this slide was, we need to address specific problems that can't be addressed with existing tools within NVO3. We need to identify what those problems are that we're trying to address in this working group, and then derive what we need to do in OEM from that. Because many of our solutions in the past have been, or many of the proposals have been passed, have been about addressing specific
right,
specific issues, rather than.
I can point to the work that's being done by Overlay OEM design team. And one of the documents that was produced by the design team was the requirement document. So there might be a good starting point to discuss and see how much of this work is applicable to NVO3 and use it as checking point list. This document might not necessarily be finished, progressed, and submitted as RFC, but it might be good to have it around to verify what we have and what we need to do.
Okay. I don't think we are disagreeing on the requirements as such. I think what we are trying to convey here is that the proposed work or whatever we're going to bring should address the requirements which are already captured, right? So the existing things do not, the existing tool set. So that means we need to do that work. And that's one of the things which outlines here. These are the proposals out there, and we need to progress forward with the pointed solutions.
Okay, any other comments? Okay, so next on the agenda is Elango, who's doing a remote presentation on Meet Echo. So Elango, I think you need to...
Yes, I'm here. Are you able to hear me?
Yeah.
And you may be able to see me as well.
Okay, we have the slides here.
Okay. Yes, on behalf of Genev authors, I'll be, giving an update on Genev, what we have done so far, and also a little bit. I'll touch upon a little bit on the next steps as well. So moving on to the next slide.
Okay.
So draft, Genev was updated on in September, and then we made, a few changes based upon the previous working group discussions, and also based on the design team recommendations. So on one of the point was to add clarifications on the critical options bit, and we did that in section 3.2. The key point here, what we clarified is it is helpful in options processing in hardware. It gives the flexibility for the hardware, the options to be processed either in the hardware fast path or in the software in the slow path. And the next point is regarding the fragmentation, and there was a discussion and also a request to add additional clarification on the fragmentation, and also add an informative reference to a similar protocol, which is actually PWE3, that also offers similar recommendation. So what we did is we provided some clarification on what are the best practices, and one of the best practices, of course, is to help to set the MTU size of the physical layer that also accommodates the encapsulation. And a similar, recommendation has also been provided in PWE3, and we provided an informative reference so that you can also refer to that. And also we updated additional references that touches upon multiple sections, and also the reference section. Moving on to the next slide.
Okay.
So okay. So on the next slide, actually, we are discussing about one of the the comments on the alternate marking proposal that was made as part of this is again a point solution as the chairs discussed earlier in the previous OAM discussion. There are many different solutions on table, and this is another one of them. And we did, as Genev authors, we reviewed the proposal to see, what if there is any impact to Genev in itself. And what we believe is, we strongly feel that this should be implemented as an extensibility, and so that the extensibility can be used not just for this solution, but also it can have wider adaptability for OAM in general, An example of such one is actually IOAM. Actually, there is a proposal that's going to come up for discussion today. That's just we are showing that as an example. But I'm not discussing about the merits of one AAM proposal versus the other OAM proposal. But what we are saying is, it need not necessarily impact the base header, but extensibility is used for such kind of purposes, so that OAM can independently evolve as an extension. And again, this depends upon if there is a working group consensus on OAM solutions in general, and then that needs to progress independent of the base protocol. And moving on to the next slide.
Okay.
So as the next steps, what we are doing is to working on adding additional description to the security best practices, and also to add potentially adding an informative reference as well in this section, as the chair already mentioned about adding an informative references, and also also to add additional clarification in there. Basically, taking some kind of the previous reviews that has happened in other similar drafts. We are taking some learning from there and proactively addressing some of those issues so that it can be helpful in the IESG review. That's pretty much what I had. Any questions or comments?
Okay. Tal.
Yeah, Tal Mizrahi, Marvell. Ilango, you mentioned the alternate marking. Did you mean that you were suggesting that alternate marking should be supported using extensibility, using tunnel options?
No, I mean, the merits of the alternate marking itself will be separately discussed as the part of the OAM solution. So what I'm suggesting is one of the, the draft specifically called out for, allocating 2 bits in the base header in order to do that. And what I'm proposing, or as on behalf of the authors, is to, use an extension for achieving such a solution, provided the working group decides to go in that direction for alternate marking for OAM.
Right. So I think my personal opinion is that adding Genève tunnel option for 1 or 2 bits is a bit costly. I think it would be much better to actually allocate this 1 or 2 bits in the Genève header.
So my point is that, I mean, this is one solution. It's not just covers the entire OAM framework, but there are multiple different proposals on table. And if all those solutions needs to be accepted, then we are allocating more and more in the base header. As such, our opinion is it's best to be addressed as an extension, so that it can not only cover this particular problem, but it could also address other use cases for OAM.
Greg Merskiziti, I would continue on what Tal said, and I agree with Tal that really using extension for 2 bits, yes, it's definitely, intuitively it's too much. I point that we already have O-bit in a header, and I think that it's reasonable to discuss the use of O-bit and whether it can be rededicated, and then we'll need only 1 additional bit for the mark. I think that it's a reasonable topic to discuss.
Kyle Rose Sandvine. You're saying, Greg, Tal, that we're only going to use 2 bits in this option, but we could always define an option that's extensible to future OAM use cases. And so it's not like we're just wasting all that space.
Then I would like to see the proposal, what else we need, because again, I'll get to this O-bit. I really don't see what the O-bit is for.
Any other
Okay.
comments? Yep. Okay. I think we're done. Thank you.
All right. Thank you.
Hi, my name is Sami Boutros. I'm going to be presenting on behalf of Daniel the security, an update to the Geneva security. Okay. Sorry, my name is Sami Boutros. I'm going to be presenting an update to the Geneva security requirement on behalf of Daniel. He is not here today. So the Geneva security requirement was presented the first time at last IETF. And since then, there were a few authors that were added, myself included, Dan as well, and Suresh. The draft went to an extensive update. So we updated the draft to mainly align. There is already a draft on IETF and NVO3 security requirement. So we updated the draft to align with the IETF and NVO3 security requirement, with focus as well on Geneva, right? So because the NVO3 security requirement was more generic to any in-cap, not really focused on a specific in-cap. So we aligned the draft to the NVO3 security requirement, and then we put specific requirement that will protect an in-cap or the NVO3 in-cap for Geneva. So next slide. Okay, so so I think this is the status. This is exactly what I mentioned. That aligning with IETF NVO3 security requirement. Sorry, yeah, it's not written right here. With a focus on the Geneva. So it's protecting the Geneva packet component. We mentioned in the draft that protecting the whole Geneva packet is out of scope because there are already solutions that can protect for that. So it's all, how to protect portion or the different packet component, which is the Geneva-based header and options, for example, right? So I think that's it. I think, yeah, the authors feel, yeah, the draft may be ready for an adoption. Or is ready.
Yeah, can maybe I get a show of hands who's read this latest version of the security requirements? Please raise your hand if you've read the latest version. Okay. Okay, I think we really need to get some more review of this, and then it does need to be adopted. But oh, yeah.
Atlas. So this is when I stand up and remind you that we really need to pay attention to the security and exhort you to please, please, please actually review the security work. Okay? We wish to have Geneva go through. We need to make sure that we are not causing substantial security issues that are going to impact the deployments, and we need to be sure that we have ways of accommodating increased security, integrity or confidentiality, particularly in multi-tenancy data centers. So please do read these if you would like to see Geneva get done. If you want to see the working group making serious, solid, and rapid, please, progress, then I need you to review documents like these yesterday. Thank you.
Okay. So next we have the EVPN applicability draft. Okay.
Good afternoon. My name is Jorge Rabadan, and this draft is applicability of EVPN to NVO3 networks. This is the my two co-authors, Matthew and Tammy. So a short introduction about the draft. So this is an informational draft, so an applicability draft, and intends to describe from a very high level how to use EVPN as a control plane for an NVO3 network. So you will notice if you read the draft that there is a long list of references, so normative and informative references. So it's kind of a reference guide pointing to the right documents in the best working group for the implementation details. So it's not a standard track document. So we are not trying to specify any new protocol or any extension to the existing EVPN. So for that, we have the best working group. And we make some assumptions here. So we make the assumption that we have a bunch of network virtualization edge devices that they need to exchange the mapping tables, the information, the MAC and IP addresses via a control plane protocol. And that control plane protocol is going to be EVPN. So the draft has this section about why EVPN in NVO3 networks. So there are certain reasons why EVPN is being used today. From a control plane perspective, we need these three things that you have in the slide. We need the auto discovery of the remote NVEs in the network that are attached to the same broadcast domain. We also need the dissemination of the MAC and IP host information, these mapping tables that you need on the NVEs in order to forward the packets with the same within the same tenant. And you also need some advanced features, things like mobility or MAC protection or the reduction of suppression of the bump traffic, multi-homing, just to name a few. So all these things you can do with EVPN. The draft also compares, well, actually tells that you could achieve some of these things using the flood and learn approach, and describes the solution with flood and learn, and then basically concludes that that solution has some shortcomings that you can actually fix with EVPN. And then you have a bunch of sections explaining how to, again, from a high-level point of view, how to apply EVPN for layer 2 services, for layer 3 services, and also for some advanced features. For instance, for layer 2 services, you can, if you have a group of NVEs that are attached to the same subnet, the same tenant, you can use the basic EVPN routes in order to do the auto discovery of the remote NVEs. And you can also use, of course, the MAC IP routes to distribute the MAC and IP information of the different hosts. And the main reference documents are the ones that you have here. So basically, the baseline RFC 7432 for EVPN and EVPN overlay, which is one of the main documents that we are referencing in this draft. For layer 3 services, you can also, if you have a group of NVEs for the same tenant, where you have multiple subnets and you need to do this inter-subnet forwarding, you can use EVPN in the control plane to advertise IP prefixes. You can advertise host routes and also IP prefixes of any length. We have this asymmetric or an symmetric model. Asymmetric means that all the subnets are attached to all the NVEs of the same tenant. And symmetric means that basically only some of the subnets are attached to a given NVE. So the symmetric model is, in that case, you need to advertise IP prefixes or host routes, and scales much better. And all the details are in these two drafts that you have here, the prefix advertisement draft and also in the inter-subnet forwarding draft. The draft also discusses some other topics like NVO3 encapsulations for EVPN, and in particular, since Geneve is the chosen one in this working group, there's a draft already that is tackling how to use EVPN for Geneve. Actually, in the slide, I have a wrong reference, but in the draft you will find the right reference. There is also some talk about OAM in the context of NVO3 and EVPN. And finally, you have a section for advanced features. You can use EVPN for those. And just to name a few, you have how to achieve VM mobility or MAC protection or duplicate detection or loop protection with EVPN, and the corresponding drafts in the best working group. You can also do smart things with the bump traffic, especially the VM originated control plane bump traffic, like how to reduce or even suppress things like ARP flooding for enable discovery or IGMP messages or even PIM messages. And there are separate draft documents for that in the best working group. Some of the things that we are describing in the draft is how to optimize ingress application, how to tackle multi-homing, how to do inter-subnet forwarding with recursive resolution, even how to do inter-subnet forwarding for multicast traffic and DCI. And again, you have a long list of reference documents and that you can check if you need to see the details. So that's pretty much it. So please read the draft, and the idea is that it has to be useful, and we would like to hear your feedback about it.
Justin, sir, I would like to prize out an extremely well-written document, very useful. I can just imagine how much work went into gathering all this information. Personally, I would like to see the document progressing. It's extremely useful.
Thank you. Thank you very much.
Okay, so can I just get a show of hands of who's read this draft? That's quite a few. Good. I mean, it'd be good to progress this fairly quickly, I think. So if you've got any comments, please send them to the list, and we'll probably go call for adoption fairly shortly.
Right. Okay, thank you.
Good morning. Seeing that the discussion about the alternate marking is already started now, it's the right moment to present this draft that is about the application of the marking methodology in the context of the NVO3 domain. So I am Giuseppe Fiocco, and this is the other authors are Greg and just a refresh about the reference model for NVO3 and NVE that I think you know very well. And just to say that the emulated layer 2 network is provided by the NVE devices, which the tenant system are connected. But the network, both layer 2 on layer 3 that can be created, can be provided by one network operator on multiple network operators. But we don't care about that because the definition of OAM in an NVO3 domain is limited to the NVO3 encapsulation. So the scope of this draft is to define a methodology that performs packet loss delay and jitter measurement for the NVO3 domain without any consideration about hierarchical layering that are out of scope here. So we want to make support the measurement per VNI between two NV devices that support the same VNI in an NVO3 domain. So now, why we need to present the marking method operation in NVO3? There is an NVO3 NCAP draft that recommends the use of alternate marking to perform the measurement and this needs 2 bits in the NVO3 header. the draft is general, so every NVO3 header can support this kind of methodology, but for now we focus on the Genève use case that seems to be the preferred and the starting point for the NVO3 standardization. So how marking method operates? Marking method split the hour flow in consecutive batches of packet by change a flag, a bit in the header. In this way, you can create consecutive batches that are unambiguously recognized along your path. And each measurement point can easily take the counter for each batches. And by comparing the counters of the batches between two measurement points, you can calculate packet in a very simple way. The same methodology can be applied for delay metrics. So we distinguished about two techniques that are single mark method and double mark method. This is the reason why we asked for 2-bit flag for the application of this methodology. With single mark method, we need just 1 bit. We can call it L bit, loss bit. With this bit, we can create the consecutive batches that I mentioned before. How about the delay measurement? We can do the delay measurement with just 1 bit by considering, for example, the first and last packet of the batches as time reference for as a timestamp reference for the delay calculation. But this can be done, but it's just an approximation sometimes because it does not work in case of auto order because the first or last packet of our batch can have an auto sequence. Otherwise, we have the average delay calculation. So for each batch, you can calculate the average timestamp. So collect the timestamp for each batch, calculate the average timestamp, and the difference between the average timestamp between two endpoints give you the mean delay. But most of people is not interested in a mean value for the batches. We consider that it depends also on the duration of the batches. If your implementation is so good that the duration of the batches is very small, also the mean information for the batches will be good because it works in case of auto order. So if you make an average timestamp in a batch, also if one packet will have an auto order, there are no problem for the average calculation. Okay. For a more precise measurement and more complete measurement, we need a double mark method. So we need to add another flag to the first one, to the L flag that we call the D flag, delay flag, for to select some special packet in our path dedicated for the delay measurement. So these packets are marked with this D flag, and so on are unambiguously recognized along our path, and we can calculate the delay. This is important because in this way you can have all the distribution for the delay in terms of minimum, maximum, delay, median, and also percentile. I would suggest to read, okay, I have described the foundation document about alternate mark method. But we are working on this technology, and I want to mention also a new draft about compact marking method that give you also some solution that use the hashing methodology for select some packet to perform delay measurement. Also multiplexing technique to use 1 bit and to perform the delay with the opposite bit and so on. So there is an advance and there is a variation of the basic and the foundation document that I suggest if you are interested you can read. Okay, this is our proposal about the Genève use case. So again, the NVO3 and CAP document suggest and consider Geneva the most suitable encapsulation for a standardization of network virtualization. And yeah, about the request of the 2-bit leader, we make this proposal to consider 2-bit leader designed dedicated for this methodology and called market bits. Okay. About next step, we can consider new application of this methodology because there is an ongoing activity on this technology. So I suggest also to read the multi-point mark graph that makes some property about the alternate marking methodology in a multi-point in a more generic and SDN-oriented context. And okay, if you have questions, comments, I suggest to read the document and give some feedback.
Okay, any comments or questions?
Greg Merskiziti, I'm co-author of this, and we do have documents in other groups, Beer, SFC, that demonstrate applicability of alternate marking method to different layers as well. So I think that interesting for NVO3 to discuss this document. Coming back to question of allocating bits, I believe that it will be good to have this discussion on the list. And in my opinion, there are options because use of O-bit and C-bit that currently allocated in a header probably could be better explained. And I think that at least in the experience discussion with the SFC working group, it was reviewed and decided that, for example, C-bit was obsolete. And the position was released back to the reserve pool. So if we want to be conservative in using reserve bits in the current Geneve header, then maybe we need to look at how allocated bits will be used in practice.
Okay, Lengo.
Yes, so specifically, I wanted to talk about the C-bit. I just mentioned that we have added additional clarification on the use of C-bit, and that's useful in hardware implementations, or it gives the flexibility for the the packets to be processed or options to be processed either in the hardware fast path or the software slow path. That information has already been updated in the tab. And the second point about the O-bit, again, this is specifically for OAM messages. So when you are processing the entire packet stream of the data packets as well as the OAM messages in the NVE endpoints, it allows and typically in the NVE endpoints you have multiple queues, and the data queues and the exceptions queues or the control queue in which the OAM messages are typically processed and sent to the OAM agent. That's in the NVE endpoint when you typically implement in the servers, and the O-bit allows to send this through the control queue, so the OAM agents can process this expeditiously as opposed to this control packets sitting behind the data queue, and that's one of the use cases for the O-bit.
Well, okay, I can refer to, I understand that SFC working group has its own reasons to deprecate C-bit, but I think that there is something to be looked at and given a thought in terms of using O-bit to prioritize processing of OEM packet. I strongly disagree with this premise because the whole idea of OEM is that you are fate sharing with their data that you are measuring, flow that you're measuring or monitoring. Doing something special for OEM really skews and alters your results. So I strongly disagree with this idea.
When the extension is specifically meant for that, architecturally, Geneva allows the extension for you to implement this. We don't see any difference because you're approximating over a batch of products. I'm not packets. I'm not even going and questioning the merits of whether your alternate marking method is, accurate and it serves its purpose. That will be, discussed separately. All I'm talking about is the proposal of using bits. Rather, the architecturally it makes sense to implement as an extension so that this can evolve independently and you can add additional capabilities to that one. For example, if you wanted to add sequence numbers to the packets, or you want to identify because you're, proposing doing timestamping on a specific packets, and this allows, you can also add additional capabilities in there in order to identify specific packets to do a timestamping. So, I mean, as I said, right, extensibility allows you to do specifically such kind of use cases, and I would strongly, recommend you to go and, look into that as a possibility.
Yes, I want to mention two things. First, we're not asking for timestamp and sequence numbers, and what Kyle mentioned that could be additional options. I invite that proposal because I think that these are orthogonal proposals. So let's stay on our request. So we're only requesting 2 bits. We're not requesting timestamp or sequence numbers. Second, what I want to mention is that we ask working group to discuss it, and I hope that working group will reach some decision that editors of the document will comply with.
Okay, thanks. I think we need to cut it off there.
I want to add that with only 2 bits, you don't need to have an extension about because we need a little of.
Can you speak closer to the mic?
Sorry. We need a little of effort more. So with only 2 bits, we don't need an extension to define an ad hoc extension to perform this kind of method. Also, my experience for the application and on the network, seeing that with the ACL, you can configure this on router and you can implement by using the current router implementation for the IP, for the IP, for example, but it can be applied everywhere, I think.
Okay. All right, thanks. Let's take the rest of the list. Next is right. Oh, you're presenting. Okay.
Surprise. Thanks. So my name is Tal Mizrahi. I'm from Marvell. Here's that. Quick. Okay. So this draft is about IOM in Geneva. As you can see, there's a long list of authors led by Frank Bruckner's. So I guess most of you probably have seen the slide. I'm going to go over it pretty briefly. In a nutshell, IOM stands for in situ OEM. And the idea is that you do full screen?
Yeah, it doesn't. It cuts the diagram.
Okay. Okay.
That's what I just did. You see?
Yeah. Okay, so the idea is that IOM allows you to integrate network telemetry information into in-flight packets, into data packets. And this avoids the need for control plane OEM messages. And you can still measure the performance of the network accurately. The base document of IOM has been accepted by the IPPM working group, so it's being discussed there. And please hold questions until the end. There's no way you already have a question.
Yeah, I'll keep.
Let's
hold. I
let's
can-
wait just
I
5
can
more
hold
minutes.
it.
Okay. So the base document of IOM defines data fields. Basically, these data fields include information which can be either included on a hop-by-hop basis or on an end-to-end basis. And this information includes, for example, information like node IDs, interface IDs, timestamps, and also other types. And IOM is defined in a way that can fit different types of encapsulations. So it can be encapsulated over IPv6, SRv6, NSH, and also Genève. This is the context of this draft. Okay, so this is, briefly, this is what IOM over Genève looks like. So we're going to have, obviously, the Genève header. And then after that, the IOM data is encapsulated in a Genève tunnel option. So we can see the Genève tunnel option header. And then it's followed by the IOM header and then the IOM data. Obviously, after that, we have the payload. And the idea is that in the Genève tunnel option, we have the option class and type, which specify what kind of OM data resides after that. So now at this point, we come to the interesting part, which is the open questions. So I'm going to mention the open issues that we'd like to talk about here, and then after that, we'll open it for questions and discussion. And obviously, we want IOM to be hardware friendly. So some of these open issues, there are two main open issues which are kind of related to the way IOM is implemented in hardware. One open issue is about the tunnel option length. And today, the way Genève is defined is that you can define a Genève tunnel option up to 128 bytes in length. So the question we're asking here is, given that we can certainly think of use cases where we'll need IOM information which is greater than 128 bytes, would it be a good idea to allow Genève tunnel options to be longer than 128 bytes? Okay, that's one question to keep in mind. Another open issue is related to the way we encapsulate IOM data into the packet. So there are two main approaches here, and we raised a similar issue this week in SFC. So we can see the figure here, which shows kind of two possible approaches, the left one and the right one. So let's say that we have 3 IOM options that we want to encapsulate in a packet. So one way to do that on the right side is to have these 3 options all as part of the Genève extensibility. So we'll have 3 different Genève tunnel options, 3 TLVs. Okay, that's the right option. And the left option is to use a dedicated protocol type for IOM. So that means that in the Genève header, the protocol type will say, after this, we have IOM. And then in the IOM header, we'll have a next protocol field, which will specify that after that, we have another IOM option. Okay, kind of like a linked list. And obviously, there are pros and cons here. So some hardware implementations find it hard to parse TLVs. So the right alternative may be difficult in some implementations. And obviously, there's also an advantage to the right alternative because the Genève header includes an option length field, which actually tells you where the end of all the options is. So if you want to just skip the options, you can do that. Okay, so it's not a clear cut between the 2 options. There are pros and cons, and we'd like to hear opinions about that. The current version of the draft describes the right alternative, which uses Genève tunnel options. So at this point, first of all, like I mentioned, the IOM base document was accepted by the IPPN working group. It's being discussed there. And this week we're presenting different encapsulation-specific drafts in different working groups. So we're presenting here the IOM over Genève. And as you can see, there are other drafts in other working groups. And basically what we would like to ask right now is to receive feedback about whether the working group is interested in adopting this work, about whether we're interested to work on this, and of course specifically related to the open questions that we raised here. So good time for questions.
Okay, let's begin. You state that the benefit of IOM is that you use data to export telemetry information rather than use, for example, IPFix, gRPC, Kafka, netcont notifications. So is that the main advantage?
There are a few different ways of how to measure the network.
No,
okay,
it's not measurement because you talk about telemetry. Telemetry is some information that is state of the node, physical resources like CPU utilization, memory utilization, buffer queues. That's a telemetry. That's not measured by the flow. And usually this being exported out of band transport. So you're suggesting to export this telemetry information using the, live traffic, and you stated this is advantage. I would like to understand why this is advantage.
Okay, so I just want to emphasize, I'm not going to focus on the term telemetry. This may be the wrong term, okay? But what we want to do here is to gather information about a path, which includes static information like node IDs and interface IDs, and state information like timestamps and queue depth and so on.
Okay, what nodes on a path NVO3 layer you want to trace? You have NVE end to end. You don't have NVE in the middle. So what are you tracing?
So if we have IOM data which is transported over a Geneve encapsulation, then intermediate nodes don't have to be Geneve nodes. They don't have to be Geneve-aware nodes.
But they don't touch Geneve encapsulation because they are usually IP nodes. They don't look in Geneve encapsulation unless they look in Geneve OEM layer.
Well, IOM is about measurement, so it's not a layer by itself. Okay, what we want is we want intermediate nodes, whether they are Geneve aware or not. We want to be able to somehow convey that measurement-related information.
Okay, so you expect that nodes, transit nodes in IP network will be aware of Geneve encapsulation and will look into Geneve encapsulation and do something with that. So you ask for layer violation.
I don't know if I want to use that term, but I think that intermediate nodes, which we want to measure, we want them to be able to update the IOM data without actually using the Geneve header.
So I think this is a good topic to take it to the list.
Yes.
And,
next, what I want to point is, can you bring to your open questions?
Sure.
I want just to point you that this is a proposal by OEM overlay design team for overlay OEM header. And that was called for adoption at NVO3 working group earlier this year. To have header with the next protocol in it. Are you aware of this?
Okay, so specifically regarding this open question,
yes, the option that you prefer to have in situ OEM after Geneve header and use next protocol and length to define the OEM information. That was exactly the proposal by overlay OEM design team for overlay OEM header.
So what's the question?
I'm questioning, are they aware of this, that they are repeating already than what was proposed?
Is that good or bad?
No, I'm just asking.
Maybe it's good.
I'm
I don't know.
not. I'm not trying to judge. I'm asking. Do you know that?
I wasn't aware of it. But if we're reusing something good that was proposed, that's great. Anyway, the current draft is proposing to use the right figure, which is the Geneva tunnel options.
Okay.
Hi, this is Uma from Huawei. I have one clarification question here. So yesterday I was talking to Frank. So is there any out of bound, like this is the max limit where IOM data can be collected, say 512
Can you
bytes?
speak closer to the mic, please?
Okay, is there any max limit on the OAM data that can be collected in the packet? It's like 500 bytes or 300 bytes, or there is no max limit? As long as your MTU supports, you can collect it, is it?
Yeah, so let's go back to the header here. So as you can see, there's a max length in the IOM header. Okay, there's a max length field. That defines the max length for that trace option.
Okay, then go to the next slide. So if Geneva has limitation of 128 bytes, then naturally the left-hand side naturally fits it, right? Because you don't have any
Right.
max limit, so you can keep on going. Is that correct?
Right. Yeah, that's exactly one of the points here. And it's one of the things that we need to consider when we choose between the options.
But what was the disadvantage though on the left-hand side? If you
Sorry?
put the next, what is the disadvantage you think in the left-hand side option?
Yeah, so again, if you want to be able to skip all the options because you're not parsing them at all, you just want to be able to skip them either to terminate the tunnel or to be able to parse the passenger, then it would be easier to use the right-hand option, which is to use the TLP.
Thank you.
Frank Partners, just to be clear, the left-hand side doesn't really exist today, right? Because it would mean, so Geneva has its own protocol option, 65 something, right? If I remember correctly, so its own ether type. So we would need to go and define new ones for doing something like on the left-hand side. So you can almost say that that is complementary, orthogonal, whatever to Geneva. So if we're writing within Geneva, tunnel option is the only option, which leads to nested lookups, which is a challenge from a hardware implementation perspective, at least to some extent. But the bigger question is really because it leads us to 128 bytes max, which is a real constraint. And so it's a concern. And if we could spare another bit or two for length in the Geneva header, that would kind of relax things quite a bit, so that I think the NCAP would be more workable. And I wanted to come back to the original discussion. So IOM does certain things. Certain things are quote unquote hop by hop, and there is a notion of a transit hop. There's also loads of things that are end to end, like, or that you can use end to end, like sequence numbering, timestamping, and others. And it depends on the use case and how you use these options. So if you want intermediate things to go and fill in, well, maybe, maybe not. I think that's orthogonal to the discussion here. What we want is a container to carry IOM data. And what happens within the container, I think it's up to what the operational domain will do with that data. Oh, we need to cut the line, right? Okay. Right. We need to cut the line. We don't
Okay.
have time.
Thanks.
Okay, so take those discussions to the list. Thank you.
So I will present you Mac move flush signaling over Geneva. So what is the use case first? So we've got two edges that are connected to an L2 access network. And those two Geneva edges are working in active standby mode to avoid loops in the L2 access network. And of course, in case of failure of the primary node, we want to signal very quickly to the rest of the Geneva fabric that's how to reach the L2 access network. So this is the goal this is a use case here for this draft. So what are we doing? We are using an OM mechanism inbound in the Genève tunnel to signal that the over edges in the fabric need to flush or move the MACs from one edge to another. The goal is to have a faster convergence, not to wait for MAC edging. That would be done normally in this case. So this in this draft, what we propose is a new TLV that would be sent by the standby edge to the entire fabric, to the rest of the NFV in the fabric there. So in this TLV, we had a sequence number and an ACK bit to make sure that the remote end have received the message and have acted on. If they don't receive any acknowledgement, we will retry with a default timer. That's basically it.
Ali Sajasi, few questions, comments.
Yes.
There's this is for data plane learning, not control plane learning.
Absolutely,
right?
yes.
Okay. And for data plane learning, how do you currently do it with the VX learning cap?
Yeah, we do.
So currently there is solution for this kind of issue has been around.
Yes.
And
Yeah.
for data plane learning, it has been around for VPLS, it has been around for PBB VPLS, and so forth. And to make it encapsulation and transport independent, RFC 6246 suggests using existing IEEE flushing. You can just send the MVRP message inside your Genève encap, indicating the VNI, and that basically understood by the remote, and it flushes the MAC address for that VNI, and that makes it transport independent. So have you given any consideration to the existing solutions?
We can, yeah.
Yeah, this is Sami Boutros. So yes, that's true. MVRP can be used to flush, but we have defined MAC withdrawal for MPLS.
The MAC withdrawal
for MPLS-TP, you are using MAC withdrawal, right?
There has been two options, both MAC withdrawal and in-band. So there is a
MAC withdrawal is in-band for MPLS-TP.
MAC withdrawal messages to LBPs.
We have MPLS-TP and MAC withdrawal. It's already an RFC.
Okay. And what is the
we send an in-band message. Yeah, so I can send you the RFC number.
So fine. If you use it in one, does that mean to reinvent the deal for the other encap? So
the idea is that like those are NVE, Genève, DTAP endpoint, and we can use our own mechanism for withdrawal. Right?
So very good. So the point that I'm trying to raise hold on a second. The MAC withdrawal in here, or MAC flushing, is not transport dependent. You need to reinvent another mechanism for VXLAN. You need to invent another mechanism for GUI, for GPE, so forth. You're doing transport dependent MAC flushing.
The working group is pushing for Genève, so that's why we.
That is besides the point. The point is, if you can easily do transport independent, then there should be a very good reason not using that existing mechanism.
I think we can discuss that.
Yeah.
Ali,
just one quick thing. When you talk about these ACK stuff, this is on a per remote node, because this gets flushed to the bunch of nodes, and then you need to keep a list of who's sending ACK, who's not sending ACK, and all that needs to be considered.
Yeah, same thing.
Yes, absolutely.
Okay.
Okay. Jorge Rabadan, Nokia. I noticed you are assigning a VTEP ID per MVE, but there is no information about how you assign those IDs and based on what. And it's kind of, I mean, it needs much more information, I think.
Yeah. Yeah. Yes.
And also how in the redundancy group, how is the active knowing, you know, the standby is there and
yeah,
and the ID and all that is. So at the moment, there's no. I mean, one reading the draft, there's no way you can implement this, right?
Okay. Okay. Fair comment. Fair comment.
Michael Smith, Cisco. Just a clarification question. I assume this is not piggybacking on data packets, right? This is independent.
Yeah. Yes, that's independent of data packets.
The protocol type would be.
Sorry.
The protocol type in the Geneva header. No. Okay.
Hi, my name is Sami Boutros. I'm presenting a draft on Geneva applicability for SFC. So SFC has defined an in-cap, the NSH in-cap. And for NSH, SFC already have defined a protocol for it, so it can be carried by any transport. So Geneva to carry NSH, that will be straightforward. Geneva already is a transport that can carry different protocols, so we simply need to put in the Geneva header protocol type for NSH, and now we can carry NSH. However, in this draft, we are trying we have a slightly different proposal on how to achieve the SFC. We still are talking about carrying the service function path information and the metadata that the NSH as well defined as option TLV into the Geneva tunnel. So we are proposing having a source routing TLV, very similar segment routing, consisting of a list of the service function. We call that option a service function list. It's simply a list of IP addresses of the service functions that the service function passes to go through. Of course, by doing this, we eliminate the need of having a pass ID or a service topology or a service forwarding table that map the pass ID and service index as defined by NSH to an IP. And as well, we can carry into another option TLV, the NSH metadata. NSH has defined metadata of type 1 fixed and type 2 variable length. So those can be carried as well as option TLV. Of course, as I mentioned, we can carry NSH as a protocol into Geneva, and that doesn't really require any draft to say so. So this is the use case here following the SFC architecture. So those NVEs can be thought as service function forwarder that are connected or directly connected to the different service function. So at the ingress NVE, we are doing the classification, and the classifier here sets the service function pass information into the Geneva tunnel as an option, and send it, and then resolve the first service function to the Geneva tunnel that's connected to the NVE or the service function forwarder that's connected or hosting. If those NVEs are hypervisors, they could be hosting the VNF function. So it will resolve it to the tunnel, to the first NVE, and then the NVE here can send the packet to the service function. And the return packet, when it comes, it can find into the service function list the next service function to go to, resolve it again to another Geneve tunnel, and the path goes on. Of course, if multiple service functions are hosted within the same service function forwarder or NVE, then you know, if the service function forwarder, we have the intelligence to send to the different service function. Now, when the last NVE or the egress NVE receive the last packet, it will forward to the last service function, and for the return packet, it can forward to the final destination or to the customer destination. There are definitely a lot of details on exactly how to do that. And I think in the previous slide, I forgot to mention that source routing TLV could be secured as well with some authentication here, following procedure described in the segment routing header draft v6. That source routing TLV can include both IPv4 and IPv6 addresses. So it's not limited to only v6, it's v4 or v6 can be into that service function list. So yeah, I'm saying, you know, yeah, please read the draft. There are lots of details that describe the exact mechanism, and as well some details about what we are gonna be passing along the packet if even service function is NSH aware or not, you know, and how are we going to pass metadata to it or keep context associated with the service function list as we are passing or going through the pass of the service function or the service function path. Okay.
Sorry, Kyle LaRose and mine. I was reading the draft at lunch and then I got distracted, so I didn't finish it. I think maybe you just explained this quickly in your last little comment there, but do you discuss how to map? So we're stripping the encapsulation before sending it to the service function.
Correct.
How do we map that packet back to the service path?
So as we were, there are two options mentioned in the draft. One option is the service function forward itself becomes stateful about what flow it's sent. So it can
it's
relate.
a proxy.
Yeah, correct. Yeah, exactly. Implementing a proxy function or pass some metadata to the service function. And when that metadata is echoed back, then you can as well look up which service function list would map to them.
So the service function now needs to be aware that it's part of a chain, which isn't really much different than what we have right now with NSH or SRv6. So what's the big advantage here over those two options?
Sorry, can you repeat again? What do you mean by?
I'm just struggling to understand why anyone would do this as opposed to just use SRv6 or NSH.
So we are really short on time. We have two more presentations to go. So
why don't
I would
you send
appreciate.
your comments over the list, right?
Yeah,
Sure.
please. Could you take it offline, Gaurav, and because we have.
So, Sami, I think he's referring to the draft which I have, the SRv6 service function, where we are doing the similar approach.
Okay, sure, we can sync up. Thanks.
Okay, these last two slots are really about VXLAN. So if we can just quickly get through the slides and then take any comments to the list so that we can finish on time, that would be really helpful.
Okay, so this is a short update on a draft that I've been working on DFD for VXLAN. So 2 version updates. We clarified, added a use case that actually what's remarkable, if I go to the last bullet, you see that there are already 2 individual implementations of DFD over VXLAN. And I think that's kind of clues us. Hey guys, can you finish this? And one of these implementations, they illustrate their use case to use the monitoring of multicast bomb traffic replicator. So, which is really nice idea of how to use BFD for VXLAN. And what we added is just to illustrate how big the overhead of extra encapsulations could be for very little load of BFD control message. So this is what lack of multi-protocol in NVO3 costs. Extra headers. But, you know, if you cannot do any better, then you have to do this. So you have outer Ethernet header, IP header, UDP header, then VXLAN header, and inner Ethernet header, inner IP header, UDP header, and then finally only BFD control message. Just for pure scientific interest, this is how VXLAN GPE will look for BFD control packet. So thanks to the multi-protocol support, it looks much nicer and more elegant. And actually, it can have either IP encapsulation to do demultiplexing of BFD control packet using well-known UDP port for the single hop BFD session in forward direction, or it can use encapsulation OEM header, and then BFD control message can go without any IP UDP overhead. So here our request to the working group. Please discuss it, and we would like adoption of this document, and we'll think that it's really due time because there are implementations. And second, would you agree or suggest to address VXLAN GPE in the same document, or you think that it should be a different document?
Oh yeah, Atlas. So I'm very happy to see the VXLAN work. It's, you know, VXLAN GP is something that we decided as a working group is not going to be standards track, and the working group needs to focus on OAM for Genève. We're happy to see stuff for VXLAN. That's what's out there and deployed. Thanks.
Okay, thank you. That's what we need, feedback.
Hi, I'm John Lemon. First, my apologies for omitting the co-authors, Fabio Maiano and Michael Smith. I recognize the lack of urgency on VXLAN GPE and instead towards Genève, but as mentioned, it's still in use, and we are actively trying to add just a little bit to it. I would appreciate if you could take a very brief look at this 5-page long draft, provide any comments about the approach towards it, and provide feedback on this. The basics of it is it's just carrying a group-based policy and using GPE to carry it so that we can carry it along with other simultaneous subheaders such as IOAM. This is an example usage of it. You notice it's a extremely short little header, not much to it. And for those that might be familiar with DraftSmith VXLAN group policy, that extends VXLAN, and this is different in that it would extend VXLAN GPE. The status of the internet draft is this is the very initial proposal. So far, it's been reviewed only by co-authors, and I'd appreciate review from others that have any interest in this. And I believe, so provide comments, and eventually we would like a code point for this, and that's it. Thank you.
Okay. All right. Thank you very much. And, want to say anything more? think with that, we're done. Thanks very much. And please take any comments on those drafts to the list. As Leah mentioned, the focus is on Genève at the moment, so we're going to push through the Genève drafts first. And see you in London. Oh, one more thing. If you have the blue sheets, could you bring them to the front, please?